Hello, my name is Patrick Weiss, and I'm here with Jacob to discuss our application called LogReader Pro. LogReader Pro allows users to take data files that they obtain from their vehicles and import it into the application. Once imported, the user is able to graph the data, as well as compare this data to historical data. Users can then choose to print or save these graphs. In this presentation, we will discuss our various usability and experience goals, our conceptual model, the requirements of our application, and how our prototype works. To begin, I'd like to talk about our usability goals. We are marketing our application to users who tune their cars. Tuning is when a person changes settings like fuel trims or timing advance in a car's ECU to improve performance, or in some cases, fuel economy. An example of the latter would be in the recent scandal in which Volkswagen used alternative tunes to get around emissions regulations. We wanted to create a tool that would allow users to easily compare various data points that arise when tuning a car. Many times, it is difficult to determine if the changes that you've made to your vehicle actually help with its performance. Our application was created to offer users the ability to import data files that they pull from their cars, and then view various charts and graphs of the data that allow them to better visualize how their changes are actually impacting their vehicle. Moving on to our experience goals. Overall, they're pretty basic. We want the application to be easy to use. Many similar applications have confusing UI layouts, and so many features that the user is easily confused and overwhelmed. We decided to keep the functionality as minimal as possible, while still meeting our usability goals. Some of the similar applications didn't even have a UI and were command-based. We wanted to offer something to our users that would not require reading a manual on how to operate it. Some of the assumptions we made when creating this application include: the user has a computer, the user has a basic knowledge on how to install an application, the user is able to pull data logs from their vehicle, and the user knows enough about tuning that they're able to infer from our charts and graphs how their tuning has affected the overall performance of their car. Now that I've covered our usability goals, I'd like to move on to our conceptual model. Overall, our users will be analyzing charts, graphs, and logs that they have imported into our system. And they're going to do that so that they can determine if the changes that they've made during their tuning has actually affected the car in a worthwhile way. As far as concepts go for our application, they include the ECU log files. These are the files that are actually pulled directly from the car, the ability to import these logs, the ability to export these logs, the ability to create charts and graphs off of the data, the ability to print these charts and graphs, the ability to organize logs, and the ability to compare log files. Out of all of our concepts, our main concept is the log file. The log file will be related to the other log files through dates. This will allow our users to compare the log files and see if their vehicle's performance has changed. So overall, they can have a running history of all the changes they've made and compare it to all the logs that they pull from their car. Our application primarily uses two interaction types: instructing and manipulating. Users will be able to instruct the application to import a log file. Once they have imported the log file, they'll be able to generate charts and graphs from this data. They can then print or save the charts and graphs as desired. As far as manipulating goes, the user will be able to change certain data points to determine how that affects the overall performance of the system. Now that I've covered the conceptual model, I would like to pass it off to Jake. He will be discussing our application's requirements and how our prototype works.
Okay guys, I'm Jake Halsey. I'm going to cover what our requirements were for the application, as well as how the application works, which I'll show you in a pre-recorded video. So to begin with, we had 4 primary use case scenarios. The user wanting to upload a new log file, then the user wants to be able to view various reports and toggle between those reports. They also want to keep track of key dates so that they can remember what changes they've made to the system. And in addition to that, they also want to be able to change the name or dates on those log files, which will simplify having multiple log files at once. They'll be able to tell which changes are actually which when you see the application will become apparent that that's actually required. There's really only one type of user, and that's the tuner. But the tuner has various experience levels, beginning from novice to kind of more intermediate to an expert tuner who's say going to be actually tuning on a dyno and being paid to do that. Now, in our case, the application is probably most useful to novice to intermediate tuners. So the first use case with that is that a user wants to upload a new file. And so in our instance, what we want them to do is just click add log and then select a file, click OK, and then the report should just pop up. And that report's going to be the average report for the log that was just pulled up. Now, the average report is going to show the average values of what we've identified as the key 5 key data points. It's going to be your RPM, your engine speed, your AFR, your knock count, and your timing advance and injector duty cycle. So typically, you want your injector duty cycle to stay under 80% while running as much advance and little fuel as you can. All right, so if we were going to talk about the requirements that are associated with that use case scenario, that would be the functional requirements are to aggregate a log, to actually upload that log to the database, and then to display the report based on that. But there are also some non-functional requirements, right? These are not computer people, so it needs to be very, very easy to use. It needs to rely on a simple menu-based system. The advantage here is that you get to take advantage of existing Windows tools or icons, so you simplify learnability by using what they're already familiar with. And then all these reports also need to be very easy to read. And that's consistent across pretty much all of our use cases. It has to be very, very simple, very, very easy to use. So the next scenario is to be able to toggle between reports, and that's as simple for us as going into a drop-down, picking the report you want, and then clicking a button called View Report, and then your new view comes up. So that would carry a functional requirement of actually being able to switch between reports, but it still meets the non-functional requirements of being relatively easy to use, at least based on our feedback so far, and relying on kind of existing conventions, going with a menu-based UI or UX. And then the reports are, we believe, easy to read. They're very simple line graphs where we've identified these kind of 5 key data points, RPM being a measure against time, so you actually only have 4 charts. And then RPM is kind of where your series is based on for each value. So you're looking at, say, what is my AFR at a given RPM? That's how you tune. So then the third scenario, you're actually getting into the user wanting to track key dates. And this is a very, very simple piece of functionality for us. All they're really doing is tracking a date and then a note about that date. So you click on key dates, it pops open a simple grid editor, which is you edit the same way you edit Excel. There's a little plus button to add a row, or you can actually just press enter at the bottom, just like you do in Excel. Tab keys, all of that works the same as Excel. So again, plus to add a row, X to delete a row, save icon to save the file, or save the table. So that's very straightforward, and that again meets that non-functional requirement of being very easy to use, being menu-driven to maintain consistency, relying on existing Windows icons to take advantage of existing knowledge and maintain an easy learnability in the system. And then it also meets the functional requirements of being able to add, delete, and modify key dates. So the last kind of scenario that we wanted to cover was to be able to actually edit the names or dates of existing logs. And the reason for this is because we use those names and dates in the captions for each of our reports. So if you have a whole bunch of logs that are named the same, you can't actually tell the difference between them. And that can happen a lot, especially when you're taking multiple logs in a single day. So that actually functions very similar to the key dates. There's a little button to open up that table, and then you just edit the 2 fields and save it. All right, so now that we've identified what all the requirements were, we're going to show you an overview of our high fidelity prototype, which is actually the second of 3 prototypes. And so before we kind of show the application, I want to explain what some of the data points that you're going to see are for. So knock count is probably the most important. That's an indicator that your engine is going to blow. Basically, it's when fuel ignites at the wrong part of the engine cycle. So to avoid knock count, what we do is actually either increase fuel or reduce advanced timing. So that's why those 2 components show. The AFR is the ratio of air and fuel together. So a higher AFR will reduce knock count, or a lower timing advance will reduce knock count. Now, to know if you actually have the ability to increase AFR, you need to know if your injector duty cycle is over 80%, which is why we monitor that data point. So the reason that you would rather add fuel than take away advance, though, is because advance is typically an indicator of power. So more advance, more power. If you were going just for fuel economy, then you would say, okay, well, let's just lower the power and not worry about it. But in most cases, tuners are actually trying to make more power.
Alright, so to start with, we're going to go ahead and open up the application, which has already been installed. Alright, here I'm just navigating to where it is on my start menu. Once it's open, what you do is start by clicking the Add Log button, and that'll bring up a file chooser to choose your first log file. And these are the sample logs that should be coming with the application, sample log 1 and sample log 2. Those will be inside the bin directory under the release folder of the install files when you get the application. Alright, now it takes a few seconds and then it begins opening up the last log average report. And I'm going to go ahead and maximize the screen here so you can see. Now, what we're mapping here is essentially 5 values: the RPM, and then 4 reports that are based against the RPM. The knock sum, the timing advance, the injector duty cycle, and the air-fuel ratio. We're going to go ahead and open up a second log here so we can open up some multi-reports. And what I'm going to do is open up these same logs a couple times so that you can get a good idea of how the multi-reports actually work. Alright, so now this is the multiple log maximum values by RPM. So similar to the average logs, it takes the maximum value at each RPM level and reports it back to you. So that's useful if you're looking for, say, a high knock, whereas an average knock is going to tell you how your car is running overall. The max knock report is going to tell you if you're getting knock at all. This is the key dates form. So this is used to keep track of changes that you make to your car, so that you can kind of put the reports into perspective once you're looking at reporting over a long period of time. So going back into the multiple logs, what we're going to do here is go ahead and play with the log editor, and we're going to change the name of those log files that shows up in those screen legends. And so we're going to change it from being log 1 and 2 over and over again to log 1 through 4. And then we're going to go ahead and view that report again, and now you can see that the log names have changed. But I've actually missed one. One of them was still named log 1 twice. So we'll go back in and change that in just a second here. And what I'm doing with the add selected button and remove selected button is just adding and removing the selected report or selected log from the drop down menu. And what that will actually do is take the log files in that key, that legend key on the right, and remove them. And it will also take the lines away. It's a little difficult to see because we're working with the same 2 log files over and over again here. The data overlaps a lot. But this helps you kind of narrow down a handful of specific logs that you want to look at, and then you can add and take them back away pretty much at will. Okay, and so this is all 4 log files, now named 1 through 4, and you can see that the data overlaps quite a bit, and it is quite hard to read. So again, we're going to use the remove button, and we're going to filter this down to just two log files, and then we can compare. And we can see in these 2 log files that quite a bit of data is missing from the duty cycle. One log completely doesn't have that value. And what typically happens in these cases, and you'll see some more here where the data is kind of missing in 1 or 2 places, what happens here is typically conversion problems during the transmission of the data over. If it can't convert, it skips over it. And so that's basically it for the application. Remember, you need to install .NET 4.5 before you can install LogReader Pro. and you can download that from our website at jcalsey.com, whack code samples, whack lpr.zip. And thanks again for checking this out. I hope you enjoy using it as much as we did making it.